And it's live. That's it.
No warm-up.
With me today on my podcast with 0 followers, I have Adam Berg. He's my brother. He's a vice president of engineering at Dubsado, and he has a number of other amazing little projects and things that he does in his free time. And I invited him here today to do a warm-up to programming in C.
Yep. Thanks.
Welcome. So I think I wanted to gear this towards anybody, but I think with that goal, basically, you don't accomplish a whole lot. So I want to assume that there's no prerequisites necessary, but at the same time, that's so ambiguous. I spent a whole summer after high school watching a lecture of a guy who put all of his computer science classes on YouTube, and I just listened to it. And he had said, like, okay, in your take-home assessment, like, it'll show you how to get set up with the integrated development environment, IDE. And I didn't have any of those paperwork, so I couldn't actually do any of the work. All I could do was stare at the code. And so here I am today to convince you that programming is a lot more simple than it looks, even though it is very complicated. So we're going to just end up with something that runs and maybe a little bit of an explanation as to where you could take it from there, or what the next level of this sort of programming would look like.
Yep. So another thing that we didn't discuss before this is, am I screen sharing myself or are you screen sharing yours?
Oh yeah, we didn't really pre-plan anything. This is jump out of the plane and then build the parachute on the way down. I was thinking if I share my VS Code with you, a live share, and give you access to the terminal, then you can just run everything perfect there. Okay. So a quick introduction. Previously, I have discussed introductions to the command line. That's what this thing is. Oops. That's what this thing is right here. That's the terminal. I do recommend being on a Mac. If you are on Windows,
Buy a new computer.
Buy a new computer, but also we can assume that you're Windows 10 or whatever greater, and it's really easy to get up and running with the Linux terminal, and it's a lot less scary than it sounds. Basically, it just gives you a shell where you can run Unix-like commands, Unix being the main difference between Windows and Mac and Linux and all these things. And basically, when we're developing, it's just a lot easier to have these style of commands over the Windows ones, even though ultimately you can accomplish the same things. So ls, go ahead, sorry.
Well, I was just going to say, I spent about 2 hours yesterday trying to get some C code compiling on a Windows computer. I intentionally didn't use the Windows subsystem for Linux, and I would have done that in the future time if I had the choice.
Okay, got it. Yeah, I mean, it's pretty fancy because you can choose whichever one that you want, Debian or Ubuntu, and it's basically just go through the Windows marketplace and everything gets installed for you. Basically, a quick introduction to the command line. I just wanted to do the ls because it shows that I'm in a directory, which you're pretty used to either on the Explorer on Windows or the Finder on Mac. And it just lists what's inside of a folder. In this case, it's my personal folder. It's my son's name, not my name. But over here, I've stepped into this web folder. So if I ls, you'll see it just lists all these things. If I ls-la, it passes in some commands. This dash feeds this guy some information that instead of listing it horizontally, now it's vertically, and we have some more metadata around it. And basically, that's everything in the shell you'll ever need to know. Make dir, mkdir, will make a directory. So we're going to make a directory called tutorial. C, and then cd means change directory, and we're going to change directory into that. And then this one, if you have Visual Studio Code installed, I think this comes for free. You can just type code and then a period to say open this current folder. But I'm not going to get into that too much. Now I just want to get started. This is Visual Studio Code, and it's pretty awesome because it's free and it does the trick. and it has plugins. So now I'm going to send it to Adam.
Whoa, does it just open in the browser these days?
The link does, yeah.
Whoa. Okay, open in VS Code. Good.
Yeah.
Installing extension.
Dun, dun, dun. 5 minutes in the podcast, I feel like we're making good headway.
Suggested contacts, guest user. I don't know if that's me or you. Continue as anonymous. See if that works. I guess I need to log in. Oh boy. It's a lot of pressure doing that live. Oh. Okay. I'm in. Request read-write access to the terminal, please. That's for you. Bottom right.
Okay. Make read write.
Oh,
Yes, Adam just did ls on my terminal, so now we have a fully integrated environment. And of course, he typed ls because whenever you get into a terminal, that's just what you do instinctively. Echo is a shell command which echoes back what you typed in.
Welcome to my echo chamber. Okay, can I kind of get started here?
Yeah,
Okay.
I think so.
I kind of have a rough layout, and we'll just see how this goes. So I think the most obvious place to begin is you create a file, main.c, c being the extension of the file. And we won't even start with hello world. We'll start with the smallest possible functional compiling C program, which should be this. I'm sure somebody's going to come out and say, oh, actually, you can put literally 1 byte and then it'll work, but whatever. I hope you have a compiler on, and I assume so because it comes with Mac. So what you should be able to do is cc main.c. So cc just uses whatever the default compiler is. I think usually on Mac it should be Clang. Look at that. So we get this a.out, and that's an executable. So you run that /a.out, and exactly nothing occurs. I'm actually surprised that this compiled because I've said, hey, so this is a function declaration. So main is a function, main being a special keyword in C to define, hey, this is the entry point to the program. And int is the return type. And why I'm surprised is because I didn't actually return anything. I would guesstimate that most compilers probably just default to returning 0. But that is probably more likely what I should have done. And so if you're familiar with Unix, and I guess Windows kind of just follows the same thing as well with status codes, when you run a program, returning 0 is basically saying, hey, this was successful. And so if I did this a.out and in the terminal to say, hey, if this thing succeeds, then do this other thing, and then I again do this echo hello, it says, okay, cool, that was successful, do the thing after it. If instead I were to recompile this, returning a -1, I haven't tested this, so hopefully this works. Great. So you can see here on the left, I think it shows on your screen too, yeah.
Mm-hmm.
There's a little red thing next to the line to say, hey, some kind of error was thrown, and that's why we don't have the echo hello called. So that's your most basic program, I would say.
Wow. That was really easy.
yeah, I had installed nothing. That's kind of the benefit of Mac OS and Linux, where logically a compiler is installed on the computer itself. There's nothing to install, you just get to run it. So then we'll maybe meander our way into more of a hello world program, and we'll do this backwards. So the command for printing something to the console is printf in C. If you're a JavaScript person, you're probably more used to console.log. Roughly equivalent, except for how you actually do it. So in the case of a simple string, it's pretty easy. You just put a string in. That's a complete lie. Don't listen to me at all. So
Just bring it back. What did you just lie about? I'm confused.
Well, I'll show you here in the error here. So if this were like console log, I could just say, hey, printf, hello world, and it should just work. But we got a couple issues here. So here it says implicitly declaring library function printf. So we'll start with that one first, and then I'll show the other error that I unintentionally but kind of intentionally made at the same time. Thankfully, people often say that like compile errors are really complicated in C, but look here, it literally tells you exactly what you need. It says, hey, you probably need to include the header stdio.h. Okay, so you can do exactly that. So imports or includes in C are done through the hashtag include and then stdio.h. And so now that will include the definitions for this printf function. And now our code should not complain about that. I kind of thought that would error. Let me see if this works. Okay, cool. So interestingly, it did not actually print anything out, which is not what we wanted. And the reason for that is because printf, the first thing it takes is actually I forget the actual name of it. I won't even pretend to make one up. Like kind of, you need to tell it what the data types of the things are. And so in this case, this is essentially a string. We'll also get into a little bit of what a string actually means in C. But %s says, hey, I'm trying to put a string in. And, oh, interesting. It shows up and then it goes away. Oh, that's just mine. Yours shows up. Okay, I was looking at my screen, not Jake's screen. Okay, I have then lied twice now. This is not a good start. All faith is being lost in me now. This does work. I'm so sorry. And that makes sense. I was confused at what I was seeing on my terminal because I don't see the actual output. That makes sense. Let me still explain the thing here. So on top of being able to put something like this, you then could also put something like a %s, and then you could kind of put it anywhere in the middle of this, and then the %s will get filled in by whatever you pass in here. So this might be hello entire world. And then we run that, and now the whole string shows up. So I got a little bit ahead of myself here, but this is kind of how you might take in different variables and kind of construct a string that you want to put in that method. Any questions from you?
I guess I think that passing the %s is confusing. Why would you want to do that?
Great question. So format string, that's what I'm looking for. So a format string, there's many of them. The ones that come to mind as notable are %d as well. I think %d refers to an integer. %f would, I believe, be a float. And then you can even have like %lf, which is like a long float, which is a 64-bit float. And without getting too deep into it, C really needs to know what the type of an object is. And so if I did something like this instead, where I said, hey, actually I'm going to be putting an integer here, but I'm not passing an integer. I actually don't exactly know what's going to happen here. Cool. So we get a warning on the compile that says, hey, you've specified the type int, but the argument has type char star. The fun thing is that it still did compile it. And so if we just run that, 218329006, what's probably happening, and this is where C gets kind of fun, and this is why and how people kind of describe it as quote unquote dangerous. My guess for that, what we get out of that number, is basically it's interpreting this string of characters as an integer. And so there's so many layers to kind of get into, but an integer probably on a modern system defaults to 32 bits. That depends on the CPU that you're running and your compiler, but pretty much most modern things should default to 32 bits. And so then this is a character string, and each character takes up 8 bits or a single byte. And so does it show my highlights? Kind of.
Yeah, it's just really light.
Okay. So my guess, and this is possibly wrong, but I think kind of correct, is when interpreting this string of characters as an integer, it will take those first 4 bytes and then just say, cool, like give me whatever integer that corresponds to. And then the %d inside the printf function, it's just making sure, okay, take this integer value and give me the string corresponding of it, because the string 218329006 is totally different than the actual integer value, where that string is 1, 2, 3, 4, 5, 6, 7, 8, 9 characters. And so as a string, that's 9 characters, 9 bytes, but the actual integer value is only 32 bits or 4 bytes. That's a really rough intro to format strings.
Yay.
Somehow getting way too deep into bits and bytes before I intended, but any other thoughts before I throw some other things into here?
No, I think that just to go back through our sort of events so far, we've said hello world, and include was our sort of first introduction to bringing in something. The include stdio.h, that is basically included in every C program ever made because you can't do anything without it.
Not totally true. So you actually only need that to print to the console. And so like lately I've been working on an actual graphical user interface. And when you're dealing with the graphical interface, you're never printing to the screen that way. And so that's more of like an operating system header file to print to the terminal. But if you're not working in the terminal, it's actually not necessary. But I will flip that completely around one more time, because the stdio includes a lot more than just printf. And I believe, if I remember correctly, it probably also includes dealing with files. So pretty quickly, yeah, you're probably including stdio.
Okay. And then including something is basically it's telling the compiler, which we didn't really introduce very much, is it's taking our basically like English words, which were defined by some human being 40 plus years ago who invented C, and then the computer wants to look at it in a very specific and just zeros and ones way, or there's a little step before that, the machine code.
Well, the machine code is essentially the ones and zeros.
Okay.
So, yeah.
Okay. So we're looking to take our English and turn it into computer. And so that's the include is what the compiler is going to come in. It's going to look at C, main.c first, because that's what we're passing into this function. We're saying, compiler, take a look at this file, which is in our root, like where we're currently inside, and then it's going to, before it even calls our function over here, it's going to say, okay, I need this library. So it's going to go and it's going to pick this library out from its own knowledge.
Yeah, so somewhere on your system, I should know this better, it's probably /user/include, I think, is where the common headers are stored. And so the compiler knows by default that's where kind of like system headers exist. And so when you say stdio.h, it will go through that folder of headers and look for that file. And then I'm pretty sure I might be oversimplifying what it does, but it's simple enough to conceptually imagine. When you say #include this file, it literally goes in and just copies that entire file in there. And then afterwards, all of a sudden, because we put include above our main function, the printf function is defined somewhere in that header file. What it actually does, probably a little bit more complicated, but conceptually that's probably the easiest way to look at it.
Okay, and so next we have argc and argv.
Argc and argv. I had to use these recently, and I thought that it was going to be more complicated than it actually is, so I'm glad it wasn't. So I said that int main blah was kind of the shortest one. Again, more specifically, you're probably supposed to put a void here to specify that you don't have any parameters. But what parameters it does allow is these two ones. So argv. And so these are kind of the standard naming conventions used for these kind of historically. And argc stands for argument count. And I think argv is probably arg values. It might be something else. But let's just, before we even tell you more about that, I'll just do so here you can see this is an integer, and this is a car **, which we might get into, we probably should get into **, but let's just pretend that you understand what it is first, and I'll show you what comes out.
Just trust us.
So here now, I will show that anytime you call a C program, there's always going to be a single argument, no matter what. And that first argument is just the name of the executable that you're currently running. Truthfully, I don't know if I've ever seen a clear use case for that, but it's kind of important and fundamental. And so here we see that the first argument that came in was 1 to say, hey, one argument has been passed to this program. And then this *** can also be written like this, which is essentially saying that this is an array of strings. And so that's why we're able to access it like this, where we say, hey, give me the first element in that array. And so now, if I were to run this program with something else as an argument, we now see that the argc parameter changed to a 2. And if I were to update this code to also put out the next argument, let's recompile, and then run this again. And now we'll see 2, a.out, and then hello. And so you can take that as far as you want to million, billion arguments. And then I'm sure you can imagine that there's libraries or even code you can write yourself to kind of just collect all the arguments that have been passed in, so that you can do things like when Jake showed earlier, the ls-al. ls is just a program, and it is a C program. And that -al is the first parameter that comes in here. And then that gets parsed and determined what additional functions should be called. Cool?
Yeah, I think we're good. I guess, wait, you went from ** to just 1 star. Was the ** an accident?
No. So, okay, we can get into the stars. The stars are really important. And maybe let's rewind a little bit into data types in C. You've got int, float, double, char. What else might be? I mean, those are probably the most immediate common ones. There's probably a few others. And then there's also modifiers on them. So you can actually have a short int. You can have a long int. And so what these do, so I haven't planned out how I would introduce these things, but basically, oops, I don't mean 32 there. So just looking at integers. So first of all, an integer is a number that has no decimal places at all. And that's kind of an important thing, especially anyone living in JavaScript land that just talks about numbers. JavaScript is interesting in that, yes, it keeps track of just the number data type, but I believe internally it actually is detecting whether it's an integer or a float and kind of stores it and computes on it differently depending. With C and most other low-level languages, you need to be extremely explicit about the actual data type you're dealing with. And so just as an example, if you were to do, okay, before we get into the other data types, let's show some more fun stuff. So let's say I think even this should work. If I did 3 divided by 2, is that going to be the math that I want? I think so. What do we got here? That show up 1. Perfect. That is the example I wanted. So if you were to, in your head, you think about 3 divided by 2, you hopefully come to the answer 1.5. What the program has given us is 1. And I'm really forgetting the correct terminology on things, which is embarrassing. But essentially, when dealing specifically with integers, where 3 is an integer and 2 is an integer, you can't have the decimal point. And so what happens is the decimal is just lost. And so here, yes, the computation would have been 1.5, but we actually just lose the 0.5 altogether, and then we're left with just the 1. If I were instead to change this to a %f, and then make any one of these numbers a float, and so this is one way to specify that a number is a float and not an integer, and then we rerun this again, we should see, yeah, 1.5, blah, 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 blah. And that's just because the compiler needs to know the data type, because internally the processor computes a float addition totally differently than it does an integer addition. And despite the fact that single 3 divided by 2 looks like one command in C, we won't get into it here, but a divide is actually like several CPU cycles that it needs to run through. So kind of an important thing to learn and understand, that just because something is one line of code doesn't mean it's actually just one operation for the CPU. So maybe coming back to these data types, it's just this long story to try to talk about what char star is.
Yeah, we can fast forward to the end.
To the char star end?
To the char star.
Okay. So a char is simply a 1 byte value, or 8 bits. If you did not know, a byte is just 8 bits. And you've probably heard the term ASCII. I'll just type it, ASCII. And what ASCII is kind of I actually recently read about this and learned a little bit more. Kind of the first thing that was defined to say, hey, with 8 bits, we can define, I think it's probably whatever, 255 specific, sorry, it's actually 256 because you have 0. 0 to 255. You can define 256 values. In English, we have 26 characters in our language, but then we also have capital letters. So there's another 26. That brings us to 52. And then if you look at your keyboard, you got all kinds of other keys. And so what ASCII did is just specified, hey, 0 means this thing, 1 means this thing, all the way up to 256. And for the most part, the English language was covered, which means now that we can store our language in these character data types. And the great thing is that it's a single byte. So especially early in the days, we're using a small amount of data to store kind of our language. Now the star comes into play where, so if I were to define a string as what most people would call a string in C, I would do something like this. And few new things here. So the char specifies, okay, this is the data type of kind of individual elements. The star refers to the fact that it's actually a pointer. And so then there's a little bit of magic that happens in the syntax here, where this is a very nice way for humans to see this because it makes a lot of sense. But internally what's actually happening is str is just a pointer, which is the star, to the first character in this. And so then in memory, it's more likely to look like, I'll just leave the capital, please, thank you. Oh boy. And so there will be a contiguous segment of memory that holds these values. But this specific variable technically only points to this address in memory. And so there's going to be some address, it's definitely not going to be 0, but there's going to be some address in memory that that variable is pointing to. And then kind of the special thing that makes this all come together, I'll just tell it, maybe I can show it as well too, is without something special, there's no way for the string to know, hey, I'm at the end of the string, because the string could always be anything. And so there's a special character that is defined like this, which is also just 0 if you were to look at it as a number. And that defines the end of the string. So despite there being 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 characters in this string, the data that stores this is actually 12 characters long in order to support the fact that this is the end of it. And so then there's a whole nother include for string that has all kinds of functions that we can do. And so if we were to do the Sterling, this, and then of course I did that wrong.
It's the code you have up top, the comment stuff.
Of course, that's not valid C. I'll just comment that out in case that's still helpful to see. That's still not it. Okay. So length 11. So you might think, hey, you just lied to me. I thought you said it was going to be 12. I did not. So strlen
I did not lie.
tells you the length of the string as you would want to hear it. So I know that there are 11 characters in the string that are actually valid. But internally, what this function is doing is it goes through each character and says, hey, is this the last character? And if you didn't supply that null terminating character, it would just go on forever. So it's just stepping through the entire string and counting all along the way to say, oh, hey, cool, that's how long this string is. So that's a very rough introduction to char star. How's that?
Yay. That's crazy. I think it's good. I think if it's something that people want to dive into further, they can essentially Google it from here. And I think we're going at a good pace to where the video type content could just be replayed if you really just wanted to watch this and, absorb more.
Yep.
Because we can. Is this in priority order? Do you want to go to debugging next? Or did we not even finish what we were going to do with the args?
No, I think that's what I wanted to show there.
It was arg vector.
Is that what it is? You just
Yeah,
looked it up?
I looked it up.
Arg values, arg vector. It's close enough.
Yeah. I don't know. So we're going to start debugging?
Yeah.
Mm.
Yeah.
Okay.
It's a very short one.
Okay.
Intentionally. But I put it there because I think it's important in any programming language, but it somehow feels a lot more important in C, especially when you're learning and don't really know what a lot of things are doing. Being able to just really see it is extremely helpful. And I don't know how this works in live share, so we'll see if this works. But there should be a debug. Oh boy, maybe you don't have it installed. Start debugging. I don't think this is what I want, but we're going to try it.
Should I install the C?
Yeah.
We might have a brief hiccup here if it needs us to reboot.
It's gotten a lot better lately.
Yeah, that's true. I mean, considering in my college days, which wasn't exactly the 1970s, we were at PCC and we had all these old Windows machines and we had an IT guy who set up all the networks and stuff. And when we got in, basically everything was pre-installed and it was.
Look at that.
It was pretty ugly back then. Run and debug. Neither of those.
No, so when I did this local, hold on, let me find mine and see if I can. I have a C/C++ debug C/C++ file as an option, which I would have thought got added by that extension you just added. And if not, we can skip this. It's not really necessary, but it's kind of cool. Find an extension for debugging C. It does feel like it probably says that it is there, but would need to be reloaded.
All right, I'm gonna reload VS Code.
Bold.
I don't see it.
Oh, that's probably what we needed.
There was a different pack.
Yeah.
CMake language support for VS Code.
Oh, but it already has the first one. Can you do Apple Shift P and then type debug?
Apple Shift P. Debug.
Yeah, there it is. That second one. So if you open up the main.c and then
Apple Shift P. Debug file.
and then just use the second one would be fine. Cool. And so it ran the function, but now if you're to put a breakpoint on line 7 or so, and then run that same debug command, it doesn't put it there. It's kind of, or you, maybe it did actually.
Maybe I can. Oh, it's running up here. But
Perfect,
oh,
yeah.
stop. Oh.
And then this is where I think it's a lot easier to kind of reason with what's going on, because it'll show you everything in the locals there. And then I actually didn't know this would happen, but it helped a lot, is you can see exactly what I was saying about the string right up top, in that first OX blah, 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 blah.
Mm-hmm.
That's the address of the starting character. And you can see even there it shows, hey, This is just H. That's all that it is.
Wow.
So that's cool. I didn't.
So str is hello world, but star str is H, and 72 is that the?
That's the ASCII for capital H.
Say ASCII. It was on the tip of my tongue, but I didn't want to be wrong.
And
oh look, we got star argv and we have star argv.
Yep. Oh, interesting. Because that's funny. I feel like when it prints it out, it doesn't show it that way. That must be the terminal probably after the fact converts it to just ./main or whatever. Oh, no, sorry, that's incorrect. We're now running through the debugger, which will run it a different way. So now this debugger is presumably running it with the full path, and that's why we see the full path there now.
Aye, aye, Captain.
So that's kind of fun.
Boom.
Yeah, and so then you could step through and whatever. If you don't know what a debugger is, that's not what we're going to talk about, but it's worth a Google.
Yeah.
If we're going further, then I will need a share again.
Oh yeah. We got about 15 more minutes, so I'm gonna squeeze out everything that I can. Wring your brain dry.
Then I think we'll do user input, and I think that's what I put next.
This podcast is brought to you by
Post-it. The only paper that sticks to a wall.
Giving inspiration to every janitor in the world. You know, that's the story behind them, right?
I actually didn't know that.
Yeah, it was just a guy, and he was like, I have this idea. I have a little bit of glue. Or no, I think he was a janitor, and he was also experimenting with a glue that was for a different purpose. But because the glue sucked at gluing, he realized that it could just be reused.
Oh, interesting. Yeah.
This is not NPR. This is very practical use. We want to make weapons out of the entire internet of people who are at home and wanting to do more with computer programming.
And Post-its are the first step, so use the coupon code POST-IT.
Post-it. Believe in yourself.
Okay, so now we've been able to kind of take some input from, say, when you call the executable itself, but pretty common. You want to be running something and then start accepting input from a user. And for probably all of today, we'll only be talking about terminal applications. And so we'll go over how you do that in C. And we'll see how much I remember, because I'm doing this off of memory. So in C, you kind of always need to define the storage for where something's going to go. I probably won't necessarily get into dynamically allocated memory today, even though that's kind of an interesting place. But effectively, this does a very similar thing. By me defining this variable, this buffer is an array, which is specified by the brackets here, of characters. And then the number inside specifies how many characters. And so then when this program is compiled, it ensures that, hey, we're going to save 1024 characters or bytes of memory for this variable. And the reason we need this is because the method for getting input from the user, there's a few. I believe fgetest is kind of one of the most recommended. And so I hope this is correct. I need to compile that to figure out. I somehow feel like I don't have access to your terminal anymore.
If you try,
I've
it
just
should
asked
ask
you
me.
again.
Boom.
Okay. course strict int file. Right. So the middle parameter is the maximum number to read, and then this is you can see down here the file that to read from. And so stdin is not necessarily globally defined, but in stdio.h is defined as the input from the terminal. And so once we do this, we should be able to make that echo program that I essentially messed around with early on here. And if I'm thinking correctly, a.out. So now if I run this, your terminal is not showing what I'm doing. Go to the a.out in the bottom right. Yep. Great. So I've run this a.out program now, and it hasn't exited. It's waiting for my input.
Oh.
And that's what that get s is doing. It says, okay, cool, don't continue until I have received some input from the user. And generally speaking, I can type as much as I want in here, and it's still not going to continue. It's not going to continue until I've actually hit enter. And so that's kind of what it's waiting on. And so if we just take this all back to the start, do this, and then it spits it out right back at me.
Yes, humility is your strong suit.
Yep. Just talk to the guy who named Linux after himself. So I was reading about how he had all kinds of other names, and he was like, I shouldn't name it after myself. And then he ended up naming it after himself. So what happens with this fgetS is it takes that input that was typed in by the user and then stores those into that buffer variable. And then maybe just for fun, let's make this a lot smaller to 4.
Oh yeah, is that going to blow it up?
Well, you're about to find out. So we run this again, and we'll put in a string larger than 4 characters. This is always my fun thing with C. What's the output going to be here?
I think it will just be the first 4 characters that it finds.
Spell it out. What do you think it's
Hell.
Okay.
We're going to land in hell.
With 2 L's, though.
No, I'm going to go ahead and guess that there's either one more or one less than expected because of some / at the beginning or the end.
So what do you think? What do you think causes us to lose an L?
I think because it's making it a string, it needs to know where it ended.
Yep. So that last character is that null character.
Did that come from the fgetS or the printf turning it into a string?
The fgetS. So the fgetS says, hey, please only give me maximum of 4, but it knows that, hey, the last one needs to be a null terminating character. So it's actually saying, actually, I'm only going to be reading 3. And then the printf needs that null character to know, hey, stop reading memory. Trying to think. Let's try something for fun.
I actually thought it was going to break. That was my instinct.
Well, so the fun thing with C is breaking is relative, and I haven't done this, so I don't know what's actually going to come out of this. But let's say that I made a string that doesn't have a null terminating character. And this is either going to be exciting or not exciting at the same time. I'm not sure. Access elements in char array. Why did I decide that B was the excess one? I think that's okay. Oh, I probably defined this wrong. Oh, I'm such a noob at C sometimes. Okay, we'll do this the slow way. Oh, I realize. Well, this is a good learning lesson because I made the mistake too. When you use double quotes in C, you're not defining a character. So I instead was kind of telling it, hey, this is a full-on another char array. Instead, we need, and maybe I can just do this the faster way, single quotes, and then it's actually defining characters. Great. Okay. I don't know what's going to happen here. Yes. Okay, that's what I was hoping for. And so this is kind of a style of blowup. And what's happening here is that printf, like I was saying, expects and requires that null terminating character. But when this buffer variable gets defined in memory, it's saved itself 4 slots. And then I've defined those 4 slots. But the memory on your computer, generally speaking, this is going to get shoved into RAM of some kind. But RAM is not always 0. It's just left at whatever it was previously left at. And so what's happened here is if we were to try this debug again, maybe that'll have a little fun thing. Well, I guess mine doesn't let me do that. Okay, that's fine. So like I was saying, the start of that buffer is that first piece of memory, that first address of memory. We get the A, we get the B, we get the C, we get the D. But printf is just blindly going until it sees a 0, essentially. And so what happens is it just goes to the next piece of memory right after that one. And here you can see a question mark, a $, and a slash. This is most likely because it's just interpreting these as ASCII. And the value at that address is whatever, maybe 222. And there's quite a few characters that just aren't defined or don't show up correctly in the terminal. That's one of them. But then you can see the $, the slash. So that's what was stored in that piece of memory. And then when it ends, should be because it randomly ran into a 0 somewhere. And this is maybe kind of a natural place to maybe tidy up, because this is kind of fundamentally the thing that people talk about when they say, hey, C is scary, C is dangerous, because this kind of a bug, as you can see, as Jake just demonstrated, I think this is why he did it, is that you can read memory that's not yours. And depending on how bad or how you craft things or whatever, you could potentially extract all kinds of information from the system that you're running on. And while it is hard to imagine that you could do this in kind of a targeted way to get the information that you want, it doesn't mean that it's not possible. And so that's kind of the whole conversation around, okay, well, C is an unsafe language, and should we even be allowing it? And then that brings into the conversation things like Rust, where they're saying, oh, hey, we can ensure via compile time checks or whatever that we are never accessing outside the bounds of something. And that's kind of the value of that. And yeah.
Yeah, nice. That's really cool. Yeah, I think I just ran it again because I just wanted to see if it was going to hit the same address space and have the same output.
Yeah, and it should be quite rare for you to get the same address when you're defining a string, because it's just going to pull some random new address.
Yeah, so everything we've done so far is running in memory.
Yes.
The only thing that ever gets put onto the disk is the actual program that we run.
Yeah, that main.c.
Yeah. So zeros are pretty frequent. I mean, it only takes plus or minus 5 steps before it hits one.
Yeah, it's all like I would be curious to know. I don't know too deep into the operating system stuff. It is possible that there is some kind of additional check that realizes, ooh, no. But it takes possibly some amount of time. That could be wrong. Because I could also imagine that, yeah, like 0 is a pretty common value to be stored somewhere in memory.
Nice. Okay, well, if we ever do get to reconvene on the next episode, maybe we could just close out by saying next steps. What's a cat program?
So a cat program is essentially starting to get into a kind of like file I/O of actually reading from the file system. And so the cat program, short for concatenate, and basically you pass in the name of the file that you would like to concatenate, and then it reads it and then spits it back out to you on the terminal. And then from there, and this is my go-to program that I build in my own time, is really simply a program that just takes input from the terminal, saves it to a file, and you're able to keep track of notes that way. And it's as simple as that.
So that's your cat program?
No, the cat program is kind of a precursor to that. In order to do so, you need to be able to read from a file to show, hey, I was able to read from this file. And then the next step is to be able to take an input from the user, much like we did with this fgetS, and then save it to a file. And so then this notes program is just bouncing between the two to say, hey, append this to the file, but then if I ask you later on to list what I've put in here, go read it from the file and then print it to the screen.
Okay, I'd ask our audience if we had any questions, but this is not shared with anybody, and it was completely unlisted. But I will be making it public and sharing it with the rest of the team a little later today. I want to make sure we end this as awkwardly as possible, because we're programmers and we don't have any style nor grace, and we're nerdy and we're big balls of losers. No, I think the thing is, my goal is to establish that everyone can be a programmer. I know that's one of your goals too. Mm-hmm. And I think it ultimately sounds a lot more complicated than it really needs to be. And I think that humans make it overly complicated, and I think we just need to sort of stop being so opinionated about everything. Stop thinking that new trendy things are great. I mean, how old is C? Like, it first appeared in 1972. Like, and JavaScript was like mid-90s because of the internet and stuff. And now we can take this C code and we can basically paste it into the internet. Like, there's really not necessarily a reason to be stuck in JavaScript or a reason to be stuck in this framework or that framework. It's kind of like if you're going to war as a developer, you don't want to just have one tool or one piece of experience. You want to at least know how to do Hello World in a variety of ways and a variety of places. So that's it for now. Hopefully we'll see you guys on the next one. Like, subscribe, and follow so that the algorithm can know that this is the content that you want. Have a good. I have just 2 minutes on the clock. I don't know how to run it out.
Do you want to run the 2 minutes on the clock?
I need outro music. And then we're gonna fade this sound.
Just do it in post.
We're gonna fade the sound down. No, I don't edit anything. I have to achieve perfection every single first try. That's what